Hi guys, in this video we're going to look at finding inverse functions. So to watch this video, hopefully you have been present for the lesson about inverse functions and what an inverse function is. However, it's not completely necessary, so if you want to take these notes just beforehand, before you come to class and learn about inverse functions, that is totally okay. So I briefly mentioned the process in class of how to find an inverse function, and these are kind of your two steps. So step one, you're going to switch your x and your y values, and step two, you're going to solve for y. So not a lot of steps here. Looking at this equation, I've got f of x is equal to 4x minus 5, and I kind of run into this little roadblock of, well, where's my y value? And so I want to take just a moment of your time to remind you, what does f of x equal? What does f of x represent? And if you said y, you are 100% correct. F of x represents all of your y values for this function, so I can simply replace f of x with y. So this is actually y is equal to 4x minus 5. Okay, now that I've got an x and y value, I'm going to just switch their locations. So wherever there's a y, I'm going to write x is equal to, wherever there's an x, I'm going to write y. So 4 times y minus 5. So at this point, I've done step one. X is equal to 4y minus 5. Now I've got to move on to step two. So now I'm solving for y. I want to get y by itself. And x doesn't have to be by itself like it is now. I just need y to be on its own. So to do that, I'm going to simply add 5 to both sides. So I'll get x plus 5 is equal to 4y. And then I'm going to solve for y. So I've got times, it's being multiplied by 4, so I'm going to divide by 4 on both sides. So y is equal to x plus 5 over 4. And this is going to be my inverse function to this top one. So these two functions are inverses. Now I can always check to make sure that I have the correct inverse function by substituting this equation into this top one, or by substituting this top equation into this bottom one. Let's try plugging this one in up here. So I'm going to have 4, this is my check. I'm going to have 4, and then in parentheses where I've got my x, I'm going to substitute this whole big thing in over here. X plus 5 over 4 minus 5. So I've got a 4 over 4 that's going to happen here. So these 4's are actually going to nicely cancel out. You could FOIL this 4 into your numerator so that you've got 4x plus 20 and simplify that way, but you can also cross it off right away. So I'll end up with x plus 5 minus 5. My plus 5 minus 5 cancels out. When I'm just left with x, I know that I have an inverse. So when I'm just left with x, that's my check for, yes, I've got it. Okay, let's look at number 2. So I've got f of x is equal to the square root of x minus 3. Thinking back, and I'll move the post-it down in just 1 minute, what's my first step to solving this problem? What do I need to do before I do anything else? Okay, before you switch x and y, and this was kind of a trick question because it's not on the post-it, first I've got to get this f of x, I've got to replace f of x with y. So this is actually y equals the square root of x minus 3. And from there, now I'm going to switch up my x and my y values. So wherever there's an x, I'm going to replace it with y. Wherever there's a y, I'm going to replace it with x. So I've got x is equal to the square root of y minus 3. Okay, so I'm done with step 1. I'll bring this post-it note down now. Now I've got to get y by itself. So I've got to solve this equation for y. Well, in order to do this, I can't just add 3 over here because this 3 is underneath the square root. So to get y by itself, first I have to get rid of this square root sign. How do I get rid of a square root? I square it. That's right. So I'm going to square this side, and I'm going to square this side. When I square something, I don't have to add a plus or a minus. That is only when I need to take a square root. So this is simply going to just be x squared is equal to, and over here, my square root will cancel out with my exponent. So I'll just be left with y minus 3. Okay, now I've got to get rid of this minus 3, so to do that I'm going to add 3 to both sides, so that I end up with y is equal to x squared plus 3. Okay, I'm going to go ahead and check my work, making sure that this is an inverse. How do I check to make sure that I have an inverse or have the correct inverse function? Okay, you should have written that you plug one of these functions into the other. One of these functions into the other. So I'm going to plug this function, what y is equal to, into this one, since I did the opposite for the last one. It should still work out. So I'm going to have, wherever I've got an x, I'm going to replace it with the square root of x minus 3. So I've got the square root of x minus 3, and then I'm squaring it to the power of 2 plus 3. Well, squaring a square root cancels out that square root, so that I'm just left with x minus 3 plus 3. My minus 3 plus 3 will cancel out. I will just be left with x. That means that this is an inverse function of this one. If you want to check and do it the opposite way, you are more than welcome to. You should end up with x. Let me know if you do not. Okay, last function that we're going to find our inverse. You've got f of x is equal to x plus 4 over 2x minus 5. What is my first step when I'm finding an inverse? Great, I'm going to write it with y, so y is equal to x plus 4 over 2x minus 5. What do I need to do next? Fantastic, I'm going to switch my x and y values. So x goes for my y. X is equal to y plus 4 over 2x minus 5. That should be a 2y minus 5. Okay, from there, what will I do next? Wonderful, I'm going to solve for y. Okay, this one's a little bit trickier. I've got a y in my denominator. In order to get y by itself, my y has to be in the numerator of my function. So how am I going to get this y out of my denominator? Wonderful. I'm going to multiply by that whole denominator on both sides. So multiply by 2y minus 5 times 2y minus 5. Okay, so over here, my denominator is going to cancel out. I'm going to just be left with y plus 4. Over on this side, I can distribute in that x so that I've got a simpler side on this side. So I've got 2xy minus 5x. Okay, so now remember my goal is to get my y's by themselves. So in order to do that, I probably have to get them to the same side. So I'm going to add this 5x over here to get it away from my y. And I'm going to subtract this y to get it closer to this one. Okay, when I do that over here, my y is going to cancel out. I'm going to have a 5x and a positive 4. Over on this side, my 5x is going to cancel out. Can I combine these two terms, 2xy minus y? No, they don't both have an x, so I cannot combine them. So this will just be 2xy minus y. Any ideas for what I can do to get this y by itself? How am I going to get rid of that 2x? How do I get those y's to just be 1y? Okay. One thing that you could try, you may have noticed that both of these terms have a y in them. So I could factor out that y so that I'm left with a 2x minus 1 is equal to 5x plus 4. Well, now I've got just one y over here, not another term with a y in it. So how am I going to get this y away from 2x minus 1? What do I need to do? Correct. I'm going to divide by this whole term, 2x minus 1. Divide by 2x minus 1. So that in the end, my inverse function is going to be y equals 5x plus 4, plus 4, over 2x minus 1. And that should be my inverse. We're going to go ahead and check it. I know this might seem like it's taking a while for just this one problem, but I want to double check that I did the work correctly. I'm going to do that over here just so that I've got a little bit more room. So check. You can pick whichever equation you want to plug into the other. I am going to plug in, let's see, I'll plug in this equation into this one because it seems a little bit simpler. Who knows, maybe it's not. So if I'm plugging in this equation into this one, that means wherever there's an x in this equation, I'm going to replace it with this whole fraction. So a lot of fraction work with this, but you want to get kind of used to it. It's going to come up more and more. So I'm going to have 5 parentheses, and now I'm going to plug in my x, so whatever this is, x plus 4 over 2x minus 5. And then I've got a plus 4 in my numerator, plus 4, over, looking at my denominator, I've got a 2 parentheses, now I'm going to plug in this whole thing again, x plus 4 over 2x minus 5. And I've got a minus 1 down here. Okay, so my goal is to simplify this out enough that I don't have to deal with it anymore, really. So I'm going to try distributing in my 2 and my 5. Let's see what happens. So I've got 5x plus 20 over 2x minus 5 plus 4 in my numerator, divided by, let's see, 2x plus 8 over 2x minus 5 minus 1. Okay, so not much simpler. Let's see what I could do. So a couple things I could try. I could try giving this a common denominator and this a common denominator to 2x minus 5. I could try doing some fraction division. One thing that you may remember from a little bit ago is how to get rid of a fraction that you don't really want. So if I don't want this denominator, notice that they've got a common denominator, 2x minus 5. I can always multiply anything by 1. So both this numerator needs a 2x minus 5, and my denominator needs a 2x minus 5. 2x minus 5 over 2x minus 5, that's just 1. And I can distribute this out to both of the terms in my numerator and my denominator. Let's see what happens. I got triggered on here because I ran out of room. Okay, when I multiply this fraction by 2x minus 5, the nice thing is that I'm going to have a 5x plus 20 times 2x minus 5 in my numerator. That 2x minus 5 is just going to cancel out, so that I'm just left with my numerator, 5x plus 20. Okay, plus, and now I'm going to multiply my 4 times 2x minus 5. Okay, no big deal. Now let's look at what's happening in my denominator. So the same thing with this fraction is going to happen as to what happened with this one. Since I'm multiplying the numerator by 2x minus 5, the numerator of this fraction by 2x minus 5, it's going to cancel out with the 2x minus 5 that's in my denominator, so that I'm just left with the 2x plus 8. Then I've got a minus 1 times 2x plus 5. Okay, this is a fraction now that I can deal with. I know what I can do with it. So I'm going to distribute what I can into these two parentheses. So really I've got 5x plus 20 plus 8x minus 20. That looks good. It looks like my 20s are going to cancel out. Over 2x plus 8 minus 1 times 2x is going to give me 2x minus 5. Okay, so like I said before, these 20s look like they're going to cancel out. These two x's in my denominator look like they're going to cancel out. Well, sorry, just noticed a slight error. You probably noticed it yourself. This should be a minus 5 over here. So this should actually be a plus 5 down here. So 5x plus 8x, that's going to give me 13x in my numerator. And then 5 plus 8 in my denominator will give me 13. This 13 over 13 will cancel out so that I'm just left with x. And I can confirm that that is an inverse function. And you are going to find the inverse of these three functions and type them into Edpuzzle. When you check your answer, it should show you the correct answer. Please check your work as you go along. Note any mistakes. You can always check your work for these as well. Okay, the last thing I want to talk about is inverses from a chart and how to figure out the values of an inverse based on a chart you have about a graph. So I'm going to start off with my function y equals x squared. This is a function that you know, and you could probably find the inverse fairly easily if you wanted to. But we're going to start off just by thinking about its x and y values. So if I plug in some x values into this function, I'll get out my y values. You should know the critical points, let's say -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4. So we've got a nice set of 5 points or 5 coordinates for my original function y equals x squared. Now, if I wanted to find the inverse values, or the x and y coordinates of my inverse function, that's actually a pretty easy thing to do. What you have to remember is basically the steps that you took at the beginning to solve an inverse equation. So your very first step is the key here. You are told to switch your x and y values. That's exactly what you're going to do here. So this is as easy as you think it will be. Whenever you have a point, so let's look at the point -2, 4, you're simply going to switch x and y. So now your x value is 4, y value is -2. If I keep going, x is 1, y is -1. So all of my points are just switching. 0, 0 will stay the same. 1, 1 will even stay the same. And then the point 2, 4 will now become 4, 2. So these will be the coordinates of my inverse function. Really easy stuff. Okay, so slightly trickier only because the notation is a little bit weird. What if I told you that for your function f of x, I gave you this table? So all of these points are your points along the line f of x. So you're given f and f of x. Well, wait a second, before you get tripped up, what does f of x represent? Oh yeah, the y values. So this is just really an x and y chart that's been turned on its side. So I've got a couple set of points, -2, -3, -1, -2, 0, 4, 1, 0, 2, 2. Okay, x and y. If I asked you to find the inverse of 0, the inverse of 0, well, we essentially did the same thing up here that we're going to do down here. So your inverse function, all of your x and y values are reversed. So your x values become y values, your y values become x values. Let's do the same thing for your inverse function. So inverse of x. We've got x and y values, and I'm going to switch them all up. So -2, 3, I'll have -3, -2. -2, -1. 4, 0. 0, 1. And 2, 2. Okay, so this table of points are the points on my inverse function. So now, if I wanted you to find f inverse of 0, so what is the inverse function at 0? Take a guess. What would that value be? Okay, if you said 4, you had the right idea. You were looking for a 0. But remember, I just replaced my 0, or replaced my x value. I replaced x with 0. So really I'm looking at where x is 0. And where x is 0, my y value is equal to 1. So you're doing the same exact process as if I had asked you, what is f of 2? And you would go along and you would look for 2, and then you would tell me what my y value was. So just as easy, you just got to create a new table. That's it for inverse functions. Come in with any questions that you have. Remember, this will be on your final exam, so you want to make sure you clarify anything that you are still confused about.